Welcome to EDU World Space.
The first part of this question asks us to look at tetrachloroethylene and basically ask us to calculate the density. So we should know that density is a measure of mass over volume, and they actually give us the mass of the sample here as 40.55 grams and the volume as 25.0 milliliters. So when we divide this out, we get 1.622 grams per milliliter for the density of the tetrachloroethylene. Notice we just have three significant figures that we're limited to because of the volume measurement. There are four significant figures in the mass, but only three significant figures in the volume. So we would have to round this answer then to three significant figures at 1.62 grams per milliliter. And that would be the density then of the tetrachloroethylene. Another part of the question had asked us, will it float on water? So the density of water is 1.0 grams per milliliter. And in order for something to float in water, it has to have a lower density than water. Well, tetrachloroethylene has a higher density at 1.62 grams per milliliter, higher than the 1.0 grams per milliliter of water. So the answer then would be no, it does not float on water because its density is higher than water. Now, the second part of the question deals with a new substance, a supercritical form of carbon dioxide. And they give us the density of the carbon dioxide as 0.469 grams per cubic centimeter. Now, you should know that a cubic centimeter is the same as a milliliter. So they ask us then if we have a 25.0 milliliter sample of the carbon dioxide, what mass of this supercritical carbon dioxide would that be? So I tell students with questions like this, always start with what you're given. They give us 25.0 milliliters. All right. And the density that we're provided with then, remembering that a cubic centimeter is the same thing as a milliliter, we just want to utilize and sort of manipulate the densities so that we have the units we don't want on the bottom and the units we do want, namely mass, on the top. And again, we're just going to substitute the fact that instead of cubic centimeters here, we're going to turn this density into 0.469 grams per milliliter. Our units are the same as the volume that's provided here. And now we can do the math to determine the mass then of the sample that we're looking at. So when we do the math, we get a number like 11.725 grams per milliliter. And we look at, or sorry, not grams per milliliter, simply grams, because we were determining the mass of this sample. So if we take a look then at the number of significant figures that we're limited to, three significant figures in each part of the calculation. So I'm limited then to three significant figures in my final answer. So 11.7 grams would then be the mass of the supercritical carbon dioxide based on the information they give me.